Okay, so how do we evaluate from this graph here if we need to evaluate f of negative 3? Zoom in on the graph if you need to. We see that negative 3 actually lines up with two segments of the graph, but one segment of the graph has a solid dot and one has an open dot. We don't want to use the open dot one because that does not include negative 3. Instead, the solid dot includes negative 3, and so the value at negative 3 is negative 1. You can also just stick the numbers into the formulas, and I had already done that in a previous problem, and this one has a detailed solution so that you can see how that's done. So I'll skip over that one. Let me go now to 24, which looks a little bit more complicated. Here we have a basketball dropping and it's bouncing off the ground, and as time goes on the height is going to be diminished. So we need to figure out g of 1.2 and g of 0.8, and we have to include the numerical, we have to include the correct units with the numerical answer. So what you want to do is consider the fact that this picture is not going to be accurate enough for you just to look at 1.2 on the picture and find an answer. Instead, you're going to want to plug in 1.2 into the function itself. Now 1.2 falls in the second range, 1 to 2.5. So we'll plug in 1.2 into this function here, and this is what it will look like. So replacing each occurrence of t with 1.2, we get g of 1.2 is equal to this value here. Now we can simplify this further, and we have negative 0.8 times negative 5.2, which, let me type that in, all clear. $4.16. So I'm looking at 4.16. Does that look reasonable? 1.2 is about here. 4.16 is about right here. Yes, that looks right. And now we want to consider the units. The units are giving me feet, seconds, feet per second, or seconds per feet. Well, this is a function that takes into account the height of a basketball after so many seconds have gone by. And so we're looking at the height is measured in feet. For the second answer, we're going to do the same thing, but plug in 0.8. This time, 0.8 is going to go into the top part of the equation. So replacing t with 0.8, now we can simplify this further. This simplifies to 0.36, so now I need to multiply 16 times 0.36 into my calculator. And I end up with 0.576. which I can tell is incorrect because I expected from 0.8, then I'd be up here between 5 and 6. So using the graph to check myself is a good thing. So what I can observe is that I typed in 1.6 instead of 16 on accident. So I try again. Now this gives me 5.76, which makes a lot more sense. And now I submit my question, and I've got that all right. Don't forget the units, because you can lose points on that. All right, so next what we have here is we're given a graph with the lines, and we need to figure out what the equations are for each of those segments. In 26, we're given the segments, and we need to figure out what the range is for each of those segments. And then for this last one, we have to figure out both. So I'm going to go through number 27, and this one also, you have to graph a piecewise function, so we'll come back to that one. And number 27 is going to work through what you need for 25 and 26. So let's work through this. First, what we want to do is just zoom in a bit here. And I can see that my first segment is going from -6 to -1 in the domain. And I can see that it's going to have a solid dot at -6 and a solid dot at -1. So I'm going to use less than or equal to for these. And then I look at the next chunk, and the next chunk is going from -1 to +2. -1 has an open circle, 2 has a closed circle. So I represent the open circle with a strict inequality and the closed circle with less than or equal to. And then for the third chunk, I'm going from -2 to +6, and I have an open circle at -2, a closed circle at +6. So that gives me the three conditions based off where they are located in terms of x. Now for the next part, I need to fill in the equations of each of these segments. So let's start with the easy one. The easy one is a flat line. The equation of any flat line is going to be y equals k, where k represents the value that every single one of those points is going to run through, which in this case is -2. So I'm actually looking for y equals -2 as the equation of the flat line. The y equals is already represented here on the left-hand side, so I just need to put the -2 on the right-hand side. Now for this next chunk, let's look at this piece over here on the right. You can extend the line as though it's going to keep going, just to get an idea of what the equation of the full line would have been. And when you do so, you'll notice that it has a y-intercept at -4. And then the slope for this is rise over run. So up 1 over 2. So the slope for this line is 1/2. So now filling in m and b to the equation y equals mx plus b, then I get the equation y equals 1/2 x minus 4. Okay, now for this last chunk on the left, I'll show you an alternative method. This is a little longer, but it's a method that always works. If you can't extend the line, you can always use the coordinates. Here we have -6, comma something. It's not clear what this is. Maybe it's 6.5, I don't know. But I don't want to use this point if it's not clear. So instead I want to use a very clear point. This one right here will work, which is -5,5. And then I want to use another clear point, so this one here will work, which is -3,2. And now if I have 2 points, I can come up with the equation of the line. First I find the slope, which by the slope formula you can calculate is -3/2. You can get that anyway just by looking at the picture here. We've got down 3 over 2, so likewise -3/2 can be found by observing the slope directly from the graph. For the y-intercept, you can use point slope form. Y minus y sub 1 is equal to m times x minus x sub 1, and then simplify, first by using the distributive property and then adding 2 to both sides. And so I have -3/2 x minus 5/2. Does that seem reasonable? Well, if I go down 3 over 2 again, I can see that the trajectory of this line is indeed to go through -2.5. So that matches what I found here algebraically. It really doesn't matter which method you use, so long as you can get an accurate equation. So let's go back to enter this. And now I can submit. Okay, what did I do wrong here? Aha, that was silly. Okay, so it's clear here that this was supposed to be a +2, not a -2. I'm not sure why I put in a -2 there. That doesn't even make sense. I can see it's a +2. But we all make those little kind of mistakes, so if it happens to you, feel human. All right, now lastly, I want to look at how to graph the function if it's a piecewise function. The key here is that you want to break the graph into two separate parts. On the one hand, you have x minus 4, and that's only for x greater than or equal to 2. And that means we have to start the graph at 2. So it might be a nice thing to do is just to plug in the point 2 into the equation and see what you get. Sorry, this isn't working the way I want it to. Okay, if you plug in 2 into the equation, you get 2 minus 4, which is -2. So that means that I'm going to have a point here at 2, -2 that has a slope of 1. So the next point would be over here. This graph is only for x less than or equal to 2. So the normal graph would look like this for x minus 4. But I can't include the whole graph. I can only include up to +2, which means I would have to erase everything to the right of +2. And then I would have a solid dot at 2, and then everything to the left still gets included, so that's why I have an arrowhead here. And then the second part starts at +2, and so I can plug in 2 into the second one as well. If I plug in 2 to this, I'm going to end up with -4 plus 1, so that would be 2, -3. And this would be an open circle for this dot. 2, -3, this is my open circle here. This has a slope of -2, go down to over 1. So this graph now is going to the right, only I do not extend it to the left. So you can see this is a little bit better drawn. They don't have arrowheads here because they just draw the line all the way off the graph. But it's the same graph. And then, so for the domain, you're going to make sure that you have a break in the graph represented if there is one. Well, it looks like you can plug in everything. There's no problem with plugging in -infinity to +2, nor after. So the domain on this is just going to be all real numbers. The range, on the other hand, oh, there's not a break for this. It just stops at -2. So everything below -2 is represented, even multiple places on the graph in some cases, but the range does stop at -2. And of course I typed it in wrong. Okay, so I said -2 out loud and then I still typed in +2. But this is supposed to be -2 as I said. Otherwise that is correct. And for this last one, this is broken into 3 separate chunks. The less than or equal to -2 chunk is the equation y equals 5. So if I start at -2 as an x value, the corresponding point is at +5. Now, anything to the left of -2 is also going to be 5. So I'm going to start here and move, whoops, that did not work out very well. Uh-oh, that didn't work either. Hold on. This tool is a little wonky. Okay, clear all. Let's try this again. I have -2, 5, and then I have a line. I think I'll have the line go from -2 to the left here, like that. That's all I need. And then the next chunk is a line that looks like -2x plus 1. I'm interested here in figuring out what would the two coordinates be here. So if I had -2 plugged in, I would have -2 times -2, which is +4 plus 1 is 5. And then if I plug in 1, I'm going to have -2 plus 1, which is -1. So this graph is going from -2, 5 to 1, -1. It's a line with a slope of -2. Now, I can notice that the open dot would be located here at 5 in the same location where the closed dot is. And if I put an open dot on top of that, that wouldn't be good because it would eliminate the closed dot that I already have. So I'm just going to put the closed dot back, knowing that I have an open dot on top of the closed dot, if it's going to let me. Come on. Nope. Okay, let me just do this again. So -2x plus 1 is only going to fill in between -2 and +1. So I'm going to use a solid dot here over here on the right. And now my last chunk is y equals 0. So I'm going to start with an open dot here at +1 at a height of 0. And now I'm going to draw a line from here to the right. Oh, that's a little off. I don't know if it's going to count me right or wrong on this, given how that's a little off there. I'm wondering. Okay, well, that's very close. If I were grading this myself, I would give me full credit. This is giving me partial credit because I don't think it likes how I graphed that last part here. If we look at the actual answer, though, you can see that the answer is the same. It's just that it's off a hair. So this is the kind of MyOpenMath issue that if a student looks at their answer key and says, hey, that's the same graph. I'm clearly off just a hair, but that's a difficult graphing tool to use. So I'm going to go in there and override those points. Now, if the person put the coordinate at a completely wrong spot, that's a different matter than just being off by a millimeter there. Okay, so that's enough for this section, and now we're going to go to 3.3.